is it the biggest or is it the smallest? Well, it's the biggest, so that's the absolute.
Maximum.
Yes.
Okay, got it.
Then we go to the one on the right here, 4, -4. Okay,
Mhm.
that is, first you check, is it the absolute min or absolute max? It is the absolute
Minimum.
min.
Mhm.
And then 12, comma 4, it's not the max, it's
Mhm.
not the min, but relative to like everything around it, it's bigger than everything around it.
Right.
So it's the relative max.
Max. Or max. Okay. Got it.
Any questions on that?
Yeah. Oh, it's pretty simple. I,
Yeah.
yeah. Oh,
All right,
yeah.
lesson over.
Yeah. Okay.
Yeah. So you do look at the endpoints.
Mhm.
There is kind of this min, and then this other place over here.
Mhm.
So you just do them one at a time. So the first one is -6, comma 4.
Or, mhm.
Is it the max, absolute max? Yes, it is. It's the absolute max. It's you first check for, is it the biggest? Is it the smallest?
Yeah.
Now you come down to this point,
Mhm.
-2, comma -2. Is
Mhm.
it the absolute min? Well, yeah, it's
Yeah.
the smallest.
Last point. Got it.
6, comma 2. The it's not a max, it's not a min, because
Mhm.
we already found the max and min. So relative to everything around it, what is it? Well, it's a relative max because relative to everything around it,
Mhm.
it's the highest.
Highest. Got it. All right. Perfect. Yeah. Okay. That's pretty simple then.
Yes.
Yeah.
All right. So the next one here, um, the thing is with this one is that you're supposed to recognize this is actually like going up and down.
Mhm.
All the other graphs were what are called like contained or bounded on the
Mhm.
left, bounded on the right.
Yeah.
Um,
I see that.
this one's not bounded above, like it goes up forever, it goes down forever. So when it goes up forever or down forever, there is no absolute min or max. And that might not intuitively make sense. You're like, but wait, it goes up forever. It's
Mhm.
because you never get anywhere. It's
Fair. There's
it's
like
a
no specific point,
yes,
basically. Yeah.
yes. But there could be a relative min and a relative max. So again, kind of comparing it to like everything around it, it's the house on the hill,
Mhm.
it's bigger, it's higher up than everything else. But if there were a house over here,
Mhm.
would be higher up, but relative to what's around it at -1, comma 0, it is
Mhm.
a relative max.
Got it. Okay, yeah, got that one. That was pretty simple. Okay, yeah. Um, submitted that one. So we can look at number 4. These are different.
The next thing is now, okay, you feel pretty good about it, and then you're like, oh, now I don't give a crap.
Mhm.
So option one is, if you have a calculator, can use a calculator, would be to graph it. Okay. Now, I don't
Graphic
know what you're gonna have on
calculator.
the test or the quiz.
Yeah.
Sorry, go ahead. Will will you be able to graph this?
Should I use like Desmos to do so?
Only if you're allowed to use it on the test or the quiz. Like that's where we got to be
I think
careful.
our tests are on paper, not on computers.
And are you allowed to use a calculator?
I am not quite sure.
Okay, so we'll kind of do a hybrid here. We're not going to use Desmos, even though that would be the fastest way to get this done.
Okay.
The first thing you do is you check the endpoints. So you find f of 0 and f of 3. All right, so
Okay.
that's putting 0 in for x,
Mhm.
putting 3 in for x. This is where I'll ask you to kind of get involved here. I'm going to do the same thing, but let's just make sure we're on the same page with how to calculate these.
Mhm. So I'm plugging in 0 and 3 for into the
Yeah,
equation. Yeah.
yep. I'm going to write that out here for you.
Yeah, I'm doing the same. 2, 3 squared. It's 2, 4. Oh my god, my calculator is. What just happened to my calculator? Sorry, I'm Okay, my calculator was being weird. Yeah, okay, got, yeah, 2 and -4.
Yeah, so we got like two ordered pairs here, 0, 2, and then 3, -4. But here's what we don't know. We don't know what happens in between them. Like it
Mhm,
could be that it goes up and then down, or it could be that it goes down and then up, or we
mhm.
really don't know, right?
Yeah.
So that's where if you have a graphing calculator available, you could save a little bit of time here. But
Mhm.
the by hand approach is to start by taking the derivative of this. What is the derivative f prime of x?
It's gonna be 4x uh -8.
8. So I may have said this before. It's like you need to know your derivatives because you're going to use them for the rest of the course. And this is
Of course.
where it is. Like
Yeah,
you're expected to like, boom, derivative, know it.
yeah, like
Now
no
you
it.
set it equal to 0 and you solve for x.
Mhm.
And so you end up getting that x equals 2. And you have to check if this is in the interval that they're giving you. You
Mhm.
may not have noticed, but it said from 0 to 3. That's where the 0 and the 3 came from, the two endpoints.
Yeah.
And you're like, yeah, it's in there. So now
Mhm.
you go back to your list and you find f of 2.
Oh, okay, so you're like plugging it back in.
Yes.
And I get -4. Wait, no. Uh,
I get
-6.
-6.
-6. Yeah, that was my bad. I was.
Okay. So um, because we got a nice graph, we can see now we can see what it actually looks like. It goes down,
Mhm,
comes back up.
mhm.
So now it's a lot like the problems we were just doing.
Yeah,
So there's the hybrid approach here is you kind of make a graph. It doesn't have to be very accurate. It just has
yeah,
to be sort of like, well, that's higher than that, and that's higher than that. So you go back here and you're like, okay, the first point, 0, 2,
mhm,
well, it's the biggest of all. So that's the absolute max.
yeah.
The next point here, which is 2, -6, it's the absolute min.
Mhm.
And then the last point, 3, -4, well, it's not the max min, but it's bigger than all the stuff around it, so it's the relative max.
Yeah. Okay, yeah, got it.
And this is where the lesson kind of comes to a grinding halt because
Mhm.
it's a little bit slower here. Now, if you had Desmos, we could be done in about 5 minutes. You just graph all of them and see it,
Yeah.
but
I think
um,
most likely he's gonna want us to handwrite it, like do all of it
exactly.
manual. We don't use any
Yeah,
technology. Yeah. Okay.
that's great. Yeah, no technology in today's world. All
Yeah.
right.
I like
Um,
doing stuff handwritten. Like I know we have calculators to like assist us, but I feel like
yeah,
there's times where it saves you time, but like you just learn better if it's all by hand.
yeah, I get it. I get it. So this one here, you always check the endpoints. So you're gonna find g of -2
Mhm,
and g of 2. So you always start with those.
mhm.
So if you could calculate those for
Yeah.
us, please.
Sorry, my brain is really slow today. It has been a long week. Um,
I mean, please use a,
yeah, I
a calculator for us.
yeah. Why is my calculator is being where I think I need to put new batteries.
Right, so that's okay. So this the first one here is
Negative
-1,
one, and then the next
and
one
then
is
the second one here is 7.
7. Yeah.
Okay, and if we were to graph that, which like all because I've got the grid paper, I can be a little bit better
Yeah.
with how I do it, but
Yeah.
you don't have to be accurate. 1, 2, 3, 4, 5, 6, 7. You don't have to be accurate. It just means like that's there and that's there. Like that's
Yeah.
good enough.
Yeah.
You do have to be able to take a derivative.
Mhm.
Um, So the derivative of this is six
X minus 6.
x squared minus six, yeah. You have to set it equal to 0. You have to be able to solve this. So this is a factoring or square root property. Can you
Mhm.
give me the two x values?
We plug it into this equation.
No.
Or
We're still not, we got to
Mhm.
get x by itself. Like,
Right.
how do you solve this?
So you have
What's this?
you have to factor it out.
You can factor or square root property, or you can tell me the numbers. Maybe you already know.
Uh, isn't it just wait, 1 and 2?
One is correct, two is
No,
not.
it's not. It's
So
uh
the square root property is the way most students probably go on this.
yeah.
You take the square root of both sides, but it's plus or minus.
So it's plus or minus positive. So you have +1 and -1.
Yes, and then you have to check, is it in the interval? Are these in the interval?
Yes.
They won't always be. Like probably in the next problem, they won't be. Now you go back and you evaluate your G at -1 and 1. That's what's kind of emphasizing, hey, you got to be able to evaluate these.
Yeah.
Uh,
And now this we can put back into our equation.
yes, the original, yes.
So it's just so the first one is 11. Or sorry, wait,
So I got different values.
I'm doing
Doesn't
something.
mean I'm right,
Yeah,
but
no, I'm doing something wrong. 2 times 1 plus
the parentheses are really important when you're
4. Yeah.
evaluating to hold on to the sign.
I got -4. Or no.
Yeah, still
Yeah.
some
Still something
off.
wrong. Yeah. I'm just trying to handwrite all of this so I don't. Doing -1 first. Why am I just negative? Is it -5? Why am I?
It's okay. Let's we can address that another time, or if we got time at the end. So the quick sketch here, now we've got -1, 7, which is up here, and then we've got a 1, -1. So what it looks like to
Oh,
me
I didn't
is
add
that,
the 3. That was my mistake.
okay,
Yeah.
glad you found that. Looks probably something like that.
Yeah.
So this may be the one where I'm not exactly sure what WebAssign Works wants, because there's typically only one absolute min and absolute max, but here they're both maxes and mins.
Mhm.
So we'll just go point by point. So -2, -1. Now let's call that an absolute min.
Mhm.
Maybe check that one
Yeah.
first before we proceed.
Yeah. Let's see. Yep, yeah, that was correct. It took both of that.
All right. And then the next one here is a -1, 7. It's an absolute max. That's truly the highest.
Yep.
And then you got the 1, -1. That's the next. That's the absolute min. And then 2, 7 is the absolute max.
Yep.
Like that.
Yep. Yeah, I got all of that.
Okay. All right.
Is the next one similar to
They're
the?
all the same from
Yeah.
here. I mean,
Yeah.
but they just get more difficult because
Oh,
they're not like nice polynomials. Like,
yeah, they're just gonna make you build up off of what you learn
yeah,
each problem.
yeah.
Yeah.
So let me grab 6. Just curious if you can hear the cat or not.
Oh, do you have cats?
Maybe not.
Yeah, I can't.
Are you still with me? I
Yeah.
apologize.
Yeah.
Just
No,
muted
yeah.
for a moment. I cannot hear you.
Asked if you have cats or.
What happened? All right, let me go test my audio again.
Mhm,
Something happened just now.
mhm.
Testing, testing.
Yeah, I can hear you.
Okay. I was unable to speak for.
Mhm.
Okay. Number 6 here is going to be snipped in. I'm stalling because it's not working. There we go. So just like the other ones, you're going to test the endpoints. And that this is where it gets even more awkward, especially
Mhm,
if you're uncomfortable with this. 3, 0 minus 1 to the 2/3 power. So
mhm,
this is 3 times negative 1 to the 2/3 power, which is the 3 on the bottom of the fraction is the cube root of negative 1 squared, and then you're going to multiply it by 3.
mhm,
Negative 1 squared is 1. The
mhm.
cube root of 1 is 1. This becomes 3.
3.
And then you do the same thing at 2.
Mhm.
3 times 2 minus 1 to the 2/3 power equals the cube root of 1 squared this time times 3. So 1 squared is 1. Cube root of 1 is 1. This is also 3.
3. Yeah.
So at this point, we have no idea what these are. I mean, they're just 2 points.
Mhm.
So we got to take a derivative. This will be maybe the hardest one. So that you're bringing that coefficient down or exponent down 2/3 times 3, x minus 1 to the minus 1/3 power. Right. And then you're setting this equal to 0. The problem is now is that then this is where you're really building on your previous classes here is you got to kind of rewrite this to know what this like looks like. It's 2 over x minus 1 to the 1/3 power. Those threes cancel. When you bring the exponent down, it becomes positive. And this is really 2 over the cube root of x minus 1, the power of 1.
And why do we bring down, or like, why do we rewrite it as 2 over x minus
Well,
1?
because I want you to see that this doesn't equal 0 anywhere.
Mhm. Okay.
And and the that's the problem. The problem is like there's nothing going on here
On,
in this
right.
one.
Because it
Like
just
like it
equals
never
0.
equals 0. This is undefined.
Fine. Yeah, because it's in the
And that's
domain.
they want you to choose 1 because it's in this domain,
Mhm.
but really it's not. So
Okay.
um, what happens though, and I want to grab a quick snip of
Mhm.
this, a
Yeah.
graph of this real quick so you can see it.
Yeah.
Um, and this would be a good one to say like, hey, Mr. Instructor or Miss Instructor, this is going to be on the test.
Mhm.
There is something that happens there, but it's like I don't know how you're supposed to know this. So when they have these fractional exponents,
Mhm.
it is always a cusp. This is called a cusp.
Okay.
And you can see there actually is a min there.
Right.
So even though it's undefined there, you have to be like, oh, I have to think about
Yeah.
that point. So it's kind of unfair. So at h of 1, it ends up being the cube root, well, 3 times 1 minus 1 to the 2/3 power. It's the cube root of 0, which ends up being 0.
Right.
So your 2 points here are 0, 0, 2, and 2, 2, and then 1, 0.
Mhm.
And so if we do it graphically, this is on the left here, this is the absolute max. This is the absolute
Isn't
max.
that 0, 3 then? If it's
Yeah,
three?
0, 3. Sorry,
Yeah,
I
0, yeah,
misspoke.
yeah.
And then this one down here is the absolute min.
Got it.
So we got 0, 3, 2, 3, 1, 0,
0.
absolute max, absolute min, absolute max.
Yeah, that one was. Okay, got it.
So you gotta be careful. Like you really I'm not sure why. Yeah, I mean, I think you just have to look out for this type of problem without getting into like
Problems. Yeah.
the minutia of why it is this way.
Yeah.
And go from there. Okay,
Yeah.
next question here is another awful one. Yeah. All right. The domain here is 0 to infinity, so you cannot check here.
Because it's just infinite.
It's infinity, but you can check at 0. So you do that part. You do k of 0,
Mhm.
2 times 0 over 5 minus 0 minus 1 to the 2/5 power.
Mhm.
So this first part it ends up being 0. That's 2
Mhm.
times 0 over 0
Yep.
over 5 0. The second part is -1 fifth root squared. So you want to try to remember these mappings of numbers. The 2
Okay.
is
Yeah.
underneath, the 5 is there, and then
Okay.
this negative is still out in front.
Mhm.
So -1 squared is 1, the fifth root of 1 is 1, so this becomes -1.
Mhm.
So that's our first ordered pair. The next thing to do is to take the derivative. So it's more complicated than the last one,
Yeah.
but it is doable here. The first derivative is 2/5. There's really a 2/5 in front of that x.
Right. It's
Um,
just that. Yeah.
and then the second one here, you bring the 2/5 down from the exponent, x minus 1 to the
Okay.
-3 over 5 power. And you set this equal to 0. So it's a little bit more involved in this one because this
Is that
time
product rule? Is that why it's -3/5?
that's just the power rule. Power rule. You're
Oh,
subtracting 1 from the exponent.
one the exponent, which is, oh, sorry, it's negative. Yeah. Oh, okay. I see. It's 2/5 minus. Okay, got it.
All right, now we'll solve this one a little bit differently. We're going to move this to the other side, so it's going to look like this: 2/5 equals 2/5 x minus 1 to the -3 over 5 power.
Mhm.
And if you multiply both sides by 5 over 2, and there's a lot of ways to solve this, so if you don't like this way, just keep that in mind.
Okay.
You can see that you get 1 equals x minus 1 to the -3/5 power.
Okay.
And then if you rewrite this on the right as x minus 1 to the 3/5 power,
Mhm.
you can do a lot of things here. You can cross multiply, you can set the bottoms equal. Um, Basically, you got to somehow convince yourself that you're setting this whole thing equal to 1.
Wait, we're,
Like if you diagonally multiply,
okay.
you end up getting that x minus 1 3/5 equals 1.
Wow, that's very complex.
Well, you're going to see here that the solution ends up being, because you undo this with the 5/3 power, the
Yeah.
5/3 power, you end up getting x minus 1 equals 1, x equals 2.
Yeah.
And then you have to check, like, is that uh
In the interval.
yeah, because it may not be.
Yeah, how do we like determine that again?
So you got to go back to the original,
Oh,
which I'm sorry, why am I scrolling here? Um, if you go back to the original,
mhm.
is it from 0 to infinity? And it is.
Is, yeah.
So that's 2 comma, and now you got to put 2 back in here,
Mhm.
which be kind of messy. Let me grab another snip of that.
So 4 minus 4/5 minus 1.
So 1 to any power,
Mhm.
doesn't matter if it's fraction or not, is 1.
1. All right,
So
great.
it's 4/5 minus 1 or 4/5 minus 5/5
Mhm.
is -1/5.
5. Yeah, gotcha.
Right, so there we go. We got the other point here.
Yep.
Now I believe you have some options for like DNE
We look.
in the like it says if nothing exists.
Yeah, it says the option is like no extremum.
Yeah,
Yeah.
because that's it. We found that you can't evaluate at that endpoint, infinity. We found the critical point. There's only one.
Yeah.
So you're just comparing these y values now, like which is bigger, which is smaller.
Mhm.
Um, so
Do you want to get it?
but kind of hang on here. There's kind of another thing going on here, which is like what happens at infinity with this thing. If you make a quick sketch, it's 0, -1,
Mhm.
and then 2, -1/5.
Yeah.
But then it's like, well, what happens from there? Well,
Yeah.
it actually, I believe, goes down forever.
Okay.
So you need some sort of a sketch. Like, how did I know that? Well, we know it's a critical point there, and it's, well, I don't know how you're supposed to know this because it's really a graphing thing,
Yeah.
but you can sort of
And
assume
I
it's a
think, yeah,
pizza really.
I'm just drawing it right now too. So,
Okay.
um,
And so this is the, I believe middle one is the absolute max, but the one
yeah.
on the left is a relative min
Mhm.
because the absolute min does not exist if it goes on forever down. This is all confirmed with technology if you have a graph,
Yeah.
which
And then variable, the last one, the variable k has no extremum because it does not exist.
yeah, that's kind of that sounds reasonable.
Yeah, I'm submitting all that.
And so actually I was wrong. Why did I wait a second here?
Yeah.
Um,
Yeah, it says
so I'm
the
looking at I graphed, I missed, this is 0, 1, no, 0, -1. This point is wrong.
yeah, D and E also is not correct. Does not exist. And then it's not a relative minimum or an absolute
Yeah,
max.
yeah. So the graph is wrong. I don't understand. I got this wrong. Why is this wrong? Um, this is positive 1/5, 2/5. Huh. Sorry, did I put 2 in down here?
I don't we did 2 minus 1 and then were we supposed to plug back in -2 or instead of positive?
So I gave you the wrong point. I'm just hurt. I don't know why. I don't know what is going wrong here. Um, let me show you the graph.
Mhm.
So I made some sort of a sign error somewhere because the this point we had 0, -1, we had that, but this other one, 1, I gave you 2, it's not 2.
Yeah.
Um, oh, it is 2. That is a point. Sorry, okay. That was right. Okay, sorry. But the other thing we didn't do is the is where the derivative is undefined.
Oh, okay.
And that it's undefined at 1, so you have to try that point to get that one. So and that's why the picture was so messed up. All right, so to clarify, oh, I don't know why I always do that.
It's okay.
Having a lot of problems today. The first point is a absolute min. This 0, -1 is the absolute smallest place. The 1, 2/5 is a relative max because it's higher than its nearby places, but not the highest because it goes up higher than that.
That correct point is 1/2.
Yes.
Yeah.
And
So
then the next one is 2, -1/5. That's this relative min. It's smaller than everything else around it, but it's not the smallest. The smallest is over here. And then there is nothing for the last one because it doesn't are no other places.
yeah. Okay, let's try that one. Yeah, that was all correct this time. Got
Okay.
it.
So
So wait,
the
one more
yeah,
time. Why is it 1, 2/5? Because what if we or
well, I
what
gave it the wrong,
was
it was the right
incorrect?
point, but I
Uh-huh.
forgot that you have to evaluate at where the derivative is undefined. So
Okay.
the derivative is undefined because it ends up going down to the denominator.
Okay.
So you also have to check that point.
Okay. Okay, got it.
All right. I think there is at least one more.
Yep, just one
Yeah,
more.
one more. All right. Okay. So again, like the others, you're going to evaluate at the endpoints. G of -1 is e to the -1 minus a -1. So this ends up being e to the -1 plus 1. A lot of students will write this as 1 over e plus 1. Plus 1, not e. like that.
Right. Mhm.
All right, and then we're gonna do the same thing at 1. E of 1 is e to the 1 minus 1, which is e minus 1. And what could be unclear is like, well, which is larger? Is it e minus 1 or 1 over e plus 1? So e is about 3. It's smaller than 3, but just for a moment, assume it's 3. 1/3 plus 1 is 4/3. 3 minus 1 is 2. So this one is a little bit bigger. Because if you can't graph this, you have to sort of be like, well, which is bigger? Well, at -1, it's
And it's
1 and a
3 because
third.
of why again? Like is just like a rule with it?
Yeah, it's like pi. It's got a
Oh,
known
okay, gotcha.
value. Without getting into like the real y, we'll just go with
Mhm,
that.
mhm. It's just always going to be 3 in any
Ish,
rule like this?
yeah.
Okay.
And then e minus 1 is about 2, so it's somewhere up there.
Okay.
All right. And so we don't know what happens in between. We again kind of like I like these types of problems because they're
Mhm.
you don't know whether it does
Gives me
that or
a
if
little
it
better.
does
Yeah.
that. We have no idea until we take the derivative.
Mhm.
All right. So derivative of g prime here, the derivative of e is itself. It's always itself. Derivative of t is 1. You set this equal to 0.
Mhm.
So when you do that and solve for t, you move the 1 to the other side. So you have e to the t equals 1. Take the natural log of both sides. So you end up getting t equals 0. So now you have to go back and evaluate the function at 0. E to the 0 minus 0 is 1 minus 0 or 1. And so that kind of clarifies that it's more this bottom graph.
Yeah.
And so now you've got your points. You've got -1 comma 1 over e plus 1. It's okay to write that.
Okay.
And that's a relative max because it's higher than the nearby points,
Mhm.
but not the highest. This 0, 1 is the absolute min because it's truly the lowest. There's
Yeah.
nothing else lower than that.
Yep.
And then the one to the right of that is the absolute max because it's higher than everything else.
Mhm. I'm gonna submit that. Yeah, okay, got all of that. That was correct.
All right. Is there some other things you'd like us to go through today?
Uh, Not at the moment. I don't have anything else to work on. That was just it.
How's class going otherwise?
It's going